Hello and Assalamualaikum everyone. Today, I, Muhammad Farhan bin Shahabuddin, together with my three friends, Jumadul Adhaar bin Hajidan, Muhammad Hafizi bin Husin, and Muhammad Airy, Firdaus bin Muhammad Razif, will be conducting two experiments. The first experiment is titration of acid and base using phenolphthalein indicator, and the second experiment is liquid-liquid extraction.
Acid-base titration is a method to determine the concentration of acid or base. A measured volume of acid or base of known concentration is reacted with sample to the equivalent point. Titration involves a progressive addition of one reactant from the burette, usually acid, to a known volume of another reactant in conical flask, usually base, until the chemical reaction of components in the solution has run into completion.
An indicator is used to show the equivalence point during a titration. The equivalence point is the point at which the moles of hydrogen ion H+ are equal to the moles of sodium hydroxide ion OH-. In other words, the reaction is complete. The completion of the reaction is usually shown by a change of color caused by a substance called indicator, which is phenolphthalein.
Now, we will be explaining about the theory of this experiment. Firstly, we look into the neutralization process, where a strong acid will react with a strong base to form a neutral pH of 7 of the solution. The equation of the reaction is as follows, where a base plus acid equal to water plus salt.
Next is about the titration indicator. Pink coloration indicates the amount of hydroxide ions OH- present in the solution. More amount of OH- will make the pink intensity of pink color is high. Otherwise, the decreased amount of OH- in solution will turn the pink color to pale pink, then to colorless. Thus, this indicates the endpoint of titration. From the graph, we can notice that the pink coloration appears at pH more than 7, which is basic solution, and colorless for pH less than 7, which is acidic solution. Some application of neutralization is determining industrial waste, to reduce acidity in food, to adjust alkalinity in soaps, and also to adjust the water quality.
Extraction is a technique that spreads compound based on solubility. In liquid-liquid extraction experiment, the liquid-liquid term means that two liquids are used in the extraction procedure. In our experiment, We use spiritory phenol to extract sodium chloride by mixing two liquids, which is methylene chloride and sodium hydroxide.
The liquid must be immiscible, which means that they will form two layers when added together, like oil and water. Some compounds are more soluble in the organic layer, which is the oil, and some compounds are more soluble in the aqueous layer, which is the water.
Firstly, we use sodium hydroxide from the conical flask. Next, we use methylene chloride as a solvent that we put in the beaker. Next, we need 2 empty beakers and a funnel. Then, clamp the separatory funnel with the retort stand. The first step is, we pour the methylene chloride to the beaker.
Make sure the stopcock of the spaghetti funnel is closed. After that, place a stone funnel in the neck of the spaghetti funnel. Then, add the extraction solvent.
For the next step, we pour the sodium hydroxide solution to the beaker.
Hence, we insert the sodium hydroxide to mix with the solvent. From that, we can see that there are 2 layers of liquid. After that, insert the stopper and pick up the spaghetti funnel.
The separatory funnel was shake gently. After we shake the separatory funnel, point the stem out and open the stopcock to release excess pressure gas. Repeat this procedure until only a small amount of pressure is released when it is vent. For our experiment, we had repeated this step for 3 times.
Next, we clamp back the funnel to the retort stand. Hence, let it undisturbed until there are 2 layers of liquid.
As we can see, there are 2 layers of mixtures, which is sodium chloride at the below and the water at the above of the mixtures. So, we need to carefully open the stopcock and allow the lower layer to drain into the flask. Drain just to the point that the upper liquid barely reach the stopcock. As the result, the water is successfully removed from the sodium chloride by using liquid-liquid extraction. Liquid-liquid extraction is a useful method to spread components compound of a mixture. When the density is less than 1, the liquid will be on the top. Meanwhile, when the density is greater than 1, the liquid will be on the bottom. The density of water is 1 gram per cm cube, while the density of sodium chloride is 2.16 gram per cm cube. Because of the density of sodium chloride is higher than the water, the sodium chloride will move to the bottom of separated funnel.